Good morning, everyone. All students in different parts of this country, all teachers in different parts of this country, and all stakeholders in the Ministry of Education. As I had earlier on introduced to you, I am going to deal with mathematics and science subjects, and those are mathematics, chemistry, and physics. And to add on that, we also have biology, which is also a science subject. I'll first begin today to tackle a particular topic which is very important in this subject called chemistry. And this topic is gas laws. Gas laws is the first topic in Form 3, a very interesting topic that gets to introduce to us how gases behave in different areas in as far as conditions are concerned. To be able to discuss the different conditions that gases may have and which may end up affecting their behavior, we shall tackle the following areas. Number one, we shall first introduce ourselves to what is matter. We shall now tailor down and be able to discuss the three different states of matter. And in the three states of matter, we shall center our discussion on only how gases are discussed in detail in as far as the conditions that affect their reactions are concerned. So to begin with, we shall discuss this thing called matter. As I had told you earlier on, chemistry is the easiest subject in the whole world, and it is a subject that is applied in different perspectives in different areas in as far as our lives are concerned. So what is matter? What a student needs to understand is that matter is anything that has mass and occupies space. Anything that has mass, it can be weighed and be able to give a certain mass or a certain weight. Number two, we are saying it can occupy space. So in terms of volume, it must be able to occupy space. So anything found on earth, anything that was created by God, can actually end up finding itself in any of the three states of matter. So we have three main states of matter, and the first one is solids, number two liquids, and number three gases. We will not discuss much about solids and liquids. We shall center our discussion on gases because the topic says gas laws. We want to be able to discuss the different laws that can actually come into existence when conditions affecting a reaction are concerned in as far as gases are concerned. So to actually be able to become so specific in our discussion, I will actually first introduce to you this thing. What is it? Number one, you should be able to understand that in solids, liquids, and gases, moving from solids to liquids to gases, the forces of attraction between the particles forming those three states of matter will actually end up decreasing. The strength of those forces reduce. Why? Because the particles tend to move far away from each other. When you look at the state of matter, which is the first one under our discussion, which is solids, you'll realize that the particles are strongly held together by strong forces of attraction. So that means that now the particles are closely packed together, forming what you call a lattice. When you move forward to liquids, the particles are somehow far away from each other. That means this reduces the force of attraction. So that tells you that in solids, the forces of attraction are stronger than the forces of attraction in liquids. Going forward to gases, you will realize that in gases, the particles are far away from each other. So that when compared to the way the particles are arranged in a liquid, you will realize that the particles in liquids are somehow closer, while the particles in gases are far away from each other. That tells you that now in gases, the forces of attraction holding those particles together are weaker. So due to this, you'll realize that now the molecules or the particles forming the gaseous state of matter will be in what you call random continuous motion, because the forces holding them together are very, very weak. So in that random continuous motion, gases tend to move at a very high speed. The rate of diffusion of a gas is faster due to the fact that the particles do not hold together with strong forces of attraction. The forces are very weaker. This allows room for them to actually be able to diffuse or move at a very high speed when compared to the rate of movement in solids and liquids. So there are two main laws that we shall discuss for today. The first law that we are going to discuss is what we call Boyle's law. Boyle was a scientist who sat down in an environment and realized that gases do behave in a particular manner when factors that affect their reaction are concerned. The factors we shall put under consideration, or the variables we shall consider in our discussion today, are: 1, we have the volume of that gas; number 2, we shall look at the temperature of the gas and the prevailing condition in as far as pressure is concerned. So to be very specific, we shall be able now to see how Boyle came up with his law in as far as the diffusion of a gas from one point to another is concerned. So what do we mean here? What we shall say here is, Boyle says that when you pick a syringe and you try to push the syringe inside the barrel, the piston tends to move towards the other end of the syringe. So this means that inside the barrel, the volume reduces. As far as my diagram is concerned, this clearly tells you that this is the handle. This is now the end from where the pushing is taking place. Inside the barrel, we have the piston pushing towards the other end of the syringe. That tells you that when pressure is exerted on the handle, the piston is pushed inwards as far as my second diagram is concerned. So when the piston tends to move inwards, that means the volume within that barrel is reduced. When the volume reduces, the gas particles will be in a continuous random motion in a way that they will end up colliding with each other and colliding with the walls of the syringe. That tells you that with the random continuous collision, that ends up increasing the pressure inside the barrel. That means when we have more collisions of the gas particles between themselves and the wall of the container, that increases the pressure. But remember, the piston has been pushed inside. That means the volume has reduced. So Boyle's law clearly tells us that under constant temperature, the volume of a given mass of a gas is inversely proportional to its pressure. My good students, what does that tell you? It tells you that when volume reduces, the pressure increases. When volume reduces, the pressure increases. What does this mean in simpler language? When the pressure is exerted on the handle, that means the piston is pushed inside. When the piston is pushed inside, the space reduces, the volume reduces. But when the volume is reducing, the gas particles will cover the shortest distance when colliding with the walls of the container. So this increases the number of collisions. Hence, this increases pressure. So, as per my drawing here, you will realize that when volume decreases, pressure increases. When volume decreases, pressure increases. When volume decreases, pressure decreases. Why? Because the space now remaining is shorter, or is shorter in terms of how these gas particles are going to cover the distance before they can collide with the wall which is actually available to them. Graphically, someone can tell you to present that information on a graph. Representing Boyle's law on a graph, for example, when you look at the y-axis, we have pressure in centimeters of mercury. On x-axis, we have the volume in centimeters cubic. Look at the shape of that graph. That means when pressure increases, the volume reduces. When pressure increases, the volume reduces. So pressure is inversely proportional to volume. So to be clear, that means that now when you'll be asked to explain as to why temperature must be constant, this tells you that temperature must remain constant because when temperature increases, the particles of the gas will gain kinetic energy. So when the particles of the gas gain kinetic energy, that means that they will actually be able to start moving at a very high speed. Hence, we cannot be able to actually extrapolate the relationship between pressure and volume if temperature is varying or temperature is increasing or decreasing. Because at the same time, temperature has an effect on the motion of gas particles. Temperature has an effect on any particle of any states of matter. So, temperature must be kept constant such that if there's any increase in pressure, it must be due to the decrease in volume brought about the pushing of the piston inside the barrel. So, what I want you to understand is that always from today henceforth, when temperature has been kept constant in any environment, a gas will end up increasing in pressure when volume has reduced. Now, I just want to actually be able to come up with the formula of calculating an unknown variable. For example, pressure or volume when one variable is actually changing. So this means, for example, so when you can look at this diagram very keenly, you realize that volume varies. Volume varies inversely as pressure, meaning when volume increases, pressure decreases. This takes us back to mathematics in a topic called formula and variation, where we say we have types of variations. For example, direct variation, inverse variation, we have joint variation and partial variation. So this actually borrows knowledge from formula and variation that has been discussed in mathematics. So this tells you volume is able to vary inversely as pressure. They are not directly related, they are inversely related, such that an increase of one variable will automatically lead to the decrease of the other variable when they are actually related to each other. So this tells you we shall drop that one and introduce a constant. So this tells you that V is equals to K over P. The K, the constant of an unknown value, has eliminated the variation sign. The K, which is an unknown value, a constant, has eliminated the variation sign. So we can say V is equals to K over P. This is the same as saying V varies inversely proportional as pressure. So if we multiply both sides by P, we will end up having the value of the constant, so that K is equals to P times V. What have I done here? I've just multiplied on both sides by P, which is actually our pressure. So on multiplying both sides by P, you realize that now on that other part of the equal sign, the P and the P will be eliminated, so that your K is equals to P times V. So that is a condition that can prevail when only one gas is being put under consideration. So just in case two gases are being put under consideration, we can actually be able to give them names. For example, we can say look at that. P1 V1 is equals to P2 V2. P1 V1 is the first condition of getting a constant when one gas is put under consideration. P2 V2 is the second condition when another gas is put under consideration. So how do they relate? P1 V1 is equals to P2 V2. It is very clear, my student, that when given such a question and you have been given at least 3 variables and you have been actually asked to get the value of the other variable, you just plug in the values given into the equation and then get the value of the known variable in as far as that equation is concerned. So Boyle, a scientist from the European nations, gave us this formula as Kenyans and another part of this world to use this as a way of calculating the pressure of a particular gas or the volume of a particular gas if conditions end up changing in as far as pressure and volume are concerned. We are saying under constant temperature. So look at this diagram. You will realize that now in this equation, if I can get the pressure and the volume of the gas, then I change the pressure, then this means the volume is also going to do what? To change. Why? Because pressure 1, volume 1 are the known values. The pressure in the second situation has actually been changed. You know, for example here, we can end up increasing pressure. When we increase pressure, we expect the corresponding volume to reduce, because we have said pressure and volume are inversely proportional to each other. So with that, you can handle any question in as far as Boyle's law is concerned. So take this assignment, please do it, so that in our next video you can be able to present your answers in as far as this law is concerned. The question reads, the pressure of a gas is 1,000 centimeters of mercury. If the volume of the gas is 2,000 centimeters cubic, calculate the new pressure if the volume is increased to 3,000 centimeters